So welcome everybody to our webinar on automotive cybersecurity. Glad to have you here or remote with the recorded session. I'm Christoph Ebert. I'm responsible in Vector for the consulting activities. And I have together with me my colleague, David Bajaj. Maybe David, you also say a few words on you.
Hi, hello everyone who are present online and also for the ones who are watching us remotely through our recorded sessions too. I also welcome you to this automotive cybersecurity training. Yeah, I am a specialist consultant at Vector Consulting and I look at the cybersecurity, ASPICE and functional safety topics. So I welcome all of you to this webinar as well. Yeah.
Okay, thanks, David. And you see already on this title slide, we have about 3 topics where I want to dive a little deeper. We have continuously updates on standards. These days, 1st July, or today is the 4th of July, which also has special meaning, but the 1st of July had a very big meaning with UNECE R.155, as you know, because now it's also mandatory for legacy. So we will certainly talk about the R.155. We have also the NES 2, which becomes effective, is active already since last year. It's a EU new cybersecurity mandated governance, but will now get to speed 17 October in many of the countries with some specific laws which now make it bring it to practice. We will talk about process, specifically also about security test, because testing is the one domain where we are really very engaged since the start of Vector. You know, we have been active in testing, and so we have our own pen test lab. We do our independent security test, and therefore also talk a lot about security test, where David is expert, so I will also might have some questions online directly to him. And we have a lot of practice experiences from our consulting projects. And in parallel, you can also send your questions in the chat and therefore also get a reply from David. If the questions come too late, we try to answer them afterwards, or we might also just have a summary of some questions at the end of this session. So my presentation will go some 50 minutes, and then we still have some 5 to 10 minutes for summarizing the Q&A. So use this because it's a real direct online possibility to interact. Few words on Vector. We are about 4,500 people active. We have about double the amount of companies with whom we work in all parts of the world. We are basically present in each single vehicle with our base software, AUTOSAR stack or real-time operating system stack. And we have different groups of products, one of them, as I mentioned, being consultant, but also we have PLM ALM support with our provision toolchain. We have the embedded software with the AUTOSAR, where we have also a lot of cybersecurity experiences. Testing with our various test products, which we heavily use for security testing, such as fuzzing and others. We have the static analysis, we have the module test with CAST. All that helps in security testing. With diagnostics, calibration, and we have the services. Along Vector Consulting, we have 4 domains, and the 4 domains, which you can also see on our nice cup here, have 4 times T. Transformation, which is we help in changes. These days, 2 major topics. One is the new ASPICE 4, which in automotive is a lot of a challenge. The other ones is the transformation towards what we call a software-defined vehicle, but also the software-defined company. So we currently have a lot of companies just to get more software spirit into their process methods. And that, of course, includes things like agile, like continuous X, etc. Trust, this is what we currently have in front of us. It's the safety competence and the cybersecurity competence. This is where we do most in our consulting project. Traditionally, functional safety, since we started Vector Consulting Services, We work along supporting a variety of standards. We bring in practical hands-on guidance, and especially on cybersecurity, we also facilitate in our test labs independent testing, which is important that you have a third-party test. We have own penetration test labs in Asia and in Europe and soon in US. And we work also currently increasingly into test with AI and for AI, where there's a lot of possibilities to grow further. We also make audits. That's important from those of you who want to get cybersecurity auditing. We also do safety assessment, so that part is also there. Technology, this is along introducing tools, introducing process, and facilitating, for instance, that all these topics which I mentioned before, such as AutoSAR provision introduction, but also code quality analysis or IT standards, IT benchmarks, that these are sufficiently well introduced. And finally, we provide all sort of training in different formats, mostly online, but also on-site, blended e-learning, and with different focus groups. So trust is the topic of the day. We're talking about cybersecurity, and that means on the one side, we have the UNECE R.155, R.156. We have the ISO 21434. We have also the ISO 27000. We have NIS. So it's a sort of standards which all come together here. Cybersecurity means continuous learning. That's why we offer these webinars, why we offer trainings, and that is also why we bring all this feedback from our own projects. Because otherwise, we soon lose grip onto what is really relevant. Technology vulnerabilities, attacks, legal exposure, all that is fast growing. We all know that. We know it from IT, where this is already known of the last 2 decades, but we see it also in automotive for 1 decade now. And we see some stimulus for more, which is on the one side, convergence of enterprise and product IT, which gives a lot of new attack surfaces, because we have with cloud connectivity now a real fluid a set of ecosystems which allow all sort of attacks. Software update management, of course, pivotal, because software update management is necessary to bring the updates into the field, but at the same time also opens the door for new types of attacks. Safety goals, a very important topic, because safety needs cybersecurity. There is no functional safety without cybersecurity. We need different modes for operational protection, and we need, of course, also be aware on changes. I mentioned already 2. I will not go to read everything, but ASPICE 4 is released, is getting active. We now bring the first trainings and consulting projects on ASPICE 4 into the market. I mentioned also NIS 2, which is the network infrastructure security, the updated regulation of European Union, which is active now and which has to be transferred into local law and is mandatory, for instance, in Germany from October onwards. Now the attacks are increasing, and we see that with a variety of recent topics. Ransomware being more and more a very important, let's say, attack. We see still man-in-the-middle attacks, but this is decreasing. We see so-called proof of concept, which show weakness, but at the same time also leads to exploits. And we see, of course, with this convergence of enterprise with the product IT, with the automotive, also a lot of attacks from the enterprise, because enterprise is much easier to attack than the vehicle. And then you can, of course, for instance, if you can sabotage some code production, some update proliferation. To give you a prominent example how this is done, increasingly developers use GenAI for code production, which we recommend not to do, because it really bears a lot of risks, or not only security, but also IPR. But what is done is, if you send the same sort of prompts from different sources with different wording to a ChatGPT 4, it will increasingly use this content of the prompt in order to refine also the way answers are provided. And that means if in your prompt is a code which has a fragment or snippet with cybersecurity, let's say a tag, that can be a link, that can be a backdoor, that code snippet will after a while also appear in the code which is provided from this GenAI environments to other users. So this so-called proof of concept has been demonstrated, and it's just one example where we see a lot of novel attacks, attack schemes. We also see a lot of new mechanisms to generate ransomware, Trojans, etc. with GenAI. So this whole picture is getting more and more challenging. Well, numbers, of course, give also the complete truth. We see an exponential growth with IoT attacks, with all sort of, let's say, topics which now impact. It's not just that we have GenAI tools for security attacks. Always on connectivity is an important thing, APIs, and insufficient cybersecurity management systems, which allow vulnerabilities to proliferate quite fast. And we see that practically all attacks these days are remotely. That means either with the enterprise or one way or the other, with code which is distributed with SUMS or directly into the vehicle, and then you can make remote attacks. Functional safety is a blind spot of many cybersecurity programs, and I come back on the relevance of functional safety in a moment. Numbers also tell that in the meantime, cybersecurity and cybercrime is more profitable than illegal drug trade. I mean, this is something which we would have not really believed still 1 or 2 years ago. But with this exponential growth, it's now really growing extremely fast, reaching $1 trillion next year. What are the current trends which we observe? Well, I mentioned some of them. We have revenue streams with new API. Think about electric vehicles, think about all these over-the-air patches and the built-in functionality which is unlocked. We had recently a case where some sort of driver seat climate system with an OEM was released as a new function. I mean, it was as a software already present, but you could activate it with a software code. The whole time between the initial release and when it was already hacked, and in the CraneNet, some code available how to activate this feature without paying for it, that was not even 1 week. And we see also that we have this converging IT and R&D departments, but that means the IT people have to learn embedded and vice versa. That is currently not the case. And that brings also a new weakness with design. So do not underestimate the criminal energy, the competence, the time of attackers, because they literally have all the time of the world and they use it. So we see a number of very different attack surfaces, vulnerabilities, which we have to protect. It's not only the car anymore, it's the car infrastructure, car to vehicle, car to infrastructure, and of course, not the least, all the different channels inside the car. We have emergency call, we have software update management, we have over the air, and all that needs to be protected. And most important, to also protect the whole chain from the initial software production to the delivery into the car. The legal exposure is growing, and I want to emphasize this topic, especially also because of NIS2. The major difference of NIS2 compared to CSMS, as we know it from UNECE R.155 and 21434, is that with NIS2, we have now a personal liability on the level of the senior management team, that is the C-suite, plus the level below. And with this personal liability, I think we have now a real eye-opener not to anymore kind of discard cybersecurity measures, but really take it serious and enforce the necessary laws, but also much more important regulations. If you think about electric vehicle, we see just with this rather small segment already a huge amount of new attack surfaces along this chain from the energy supply into the car. I mean, this is a major interface. We have also other interfaces, traditional interfaces. And we see also that if we go to the root causes, it's not always a technology weakness. It's in many situations also just a weak CSMS, and therefore also needs to be handled really end to end. That's why we have these seminars, why we have these webinars also available for you freely, because we really want to emphasize the relevance of a cybersecurity management system and the relevance of practicing state-of-the-art method, which we are going to share with you. Now, if we dive into the root causes, one topic which we see in most of the, let's say, attacks which we look into is really that too often the processes are homemade, as we say. And I will give you just a recent example because I had it last week, and it was so surprising in, I should say, its ignorance of professional engineering that I was really surprised. There was a rather big OEM approaching us to get support for their homemade tools. And I mean, then you should think about it's 2024, and there's an OEM whose core competence is, well, cars, vehicles, mobility. And then they start to build homemade tools. And I was really thinking, is this the way, what we call professional engineering? How would they ever be able to make professional tools, really professional tools, if they just start now and try then to use these tools in environments which are safety critical, which are subject to cybercrime? And I mean, we build tools, and I don't tell that because we build tools so that you buy our tools, because I mean, our tools are anyway bought. I'd simply say that because as a tool maker, we know that to become a real good professional, we talk about 10 years, 20 years. It's companies like IBM, it's companies like us who are really experienced in tool, and not somebody who decides on the spot, let's now make a continuous X tool chain, or let's now make a modeling tool inside our own company. So one clear warning, which I want just to emphasize, because it's just seemingly not disappearing, is stay with your core business. Don't try new domains where you have no experience, because cybersecurity would not stop. I mean, cybersecurity attacks all software which you use inside or outside your company. And the liability, that will always fall to your own feet. Now, another topic is that we really lack systematic requirements engineering, systems engineering, namely, and that of course also contributes towards cyber attacks. So you see in that statistics, which we draw from own experience, but also some external reports, that a lot of attacks and vulnerabilities come from configuration, some from vulnerable code, end user, that is user UX of the system, so the usability and also user experience. And along all that, if you go to the root, we will always find that in many cases it was not really specified how to test, how to design the software, and that goes back to the requirements. So our other recommendation is here, use negative requirements. That's a major need. Not just positive requirements as a set of features. We have typically endless feature lists, but we have far not enough so-called negative requirements, misuse cases, abuse cases, confuse cases, the latter being for the UX. And with these negative requirements, also test the negative requirements. That's, for instance, what we are doing in our pen test labs. And that is also the reason why we strongly recommend independent verification validation. Now I come to the standards, because this is really the basis for professional working. The standard, simply speaking, is state of the art, and that means that is what is expected from the engineers when they bring a product to service. So you see this building in a way that we have a baseline of process, and at the bottom part which is the ISO 9000 series and which is the ISO 33000 series, which are, for instance, used in ASPICE, which build the foundation where you find traceability in all these topics. If we move upwards, I built here 3 major vertical tiers. One is functional safety, where we have generally the 61508, we have the 26262 here in automotive. We have increasingly also new standards like the 21448, which is SOTIF. We have specific standards, also regulations for automatic driving. We have cybersecurity, where we have the governance level. This is, for instance, NIS2. We have the product IT with the ISO 21434. And we have also the ISO 27000 for enterprise IT, which, as I mentioned, converge. And that means we also have to observe both level of standards. Finally, we have the homologation in automotive, specifically with the vehicle approval based on the UNECE regulations. We have currently about 170 such regulations, 155 for CSMS, 156 for SUMS. We have further such regulations like the 157 and others, etc. And we have also these regulations really as checklist for the homologation process. Now let's get into methodology, because it's then also easier to understand what it really means to develop for cybersecurity. And the parallelism is obvious with this picture. When we talk about risk-oriented engineering, what it means is that we assess a risk, we realize it could be unacceptable because of high impact or high feasibility or high probability, and we mitigate it with design methods, with robustness, with redundancy. Different mechanisms are there. And this is exactly what we had over decades practiced for functional safety. Now we apply the exact same scheme also for cybersecurity. So the good news is we have same methodology on the level of risk-oriented engineering, but we translate it into different schemes. Safety primarily driven by probabilities, security primarily driven by what we could call a feasibility, an attack window. And therefore, if we go to this red box, which gives you all the foundation of how to work with risk-oriented engineering, safety means it's a severity, that's an impact, times exposure, that's the probability, that's the way how this could really be happen. And it still also includes controllability, which is to which degree can you influence in the worst case. In security, we also have the severity. We have the feasibility in terms of ease or likelihood to perform an attack. So this is a difference because the probability is not really meaningful with cybersecurity. And we have risk-oriented security engineering, which means to intelligently apply security controls to control the impact of such attacks. I will talk about a lot of such security measures down the road of this webinar, and much more, of course, in our trainings, so that you really get a better understanding here. Now, standards mean that we also are able not only to focus linear on one standard, but that we always see the different standards in context. I mentioned already the ISO 33000, which means ASPICE. And one concept in ASPICE, for instance, is in the new ASPICE 4 is that there's a very strong focus now on the right side of the V. There's a new domain validation. We didn't have that before. We were always pushing for that as industry practitioners, and now finally also the theory people have realized that the right side of the V is not the theory, it's much more practice. And therefore we really focus on verification validation also in security, but it means also together with traceability, these are foundations in ISO 33000. They apply to all the other ISO standards which we talk here about. These ISO standards by definition are not repeating content of other standards. They rather refer to as related standards. Simply speaking, if we have functional safety being an asset, ISO 21434 would not really explain what is functional safety, because we have a very good other standard on that. But it's important to really keep eyes open to understand the standards in their coherence, because they overlap. The only thing which they don't really tell is how much they overlap. This is practitioners and our guidance which we give you. But it's important to see that if you want to be successful with standards, implement them efficiently. And that means don't focus on one standard, always see what dependencies, how can you most efficiently use content from other standards. And for heaven's sake, don't build groups which only look to one standard. If in your organization, if there is a group which is doing QM, have them to look on all applicable standards. Not security people on security standard, safety people on safety standard. That will not work. Standards are interdependent. And our recommendation here is, for instance, if you make an application matrix for traceability and status, we always do that with our customers. So we see what are the clauses and in which of their internal guidelines they have covered the one or the other clause. Then we can see rather easily gaps. But having said all that, and knowing the relevance of safety and cybersecurity, maybe, David, you want also to share some experiences from your projects.
Yes, thank you so much, Christoph. So, yes, when we talk about safety and security, we in the picture also we saw that the top is always the product liability. That is, we always talk about trust. That is the foremost T that we talked about before. So yes, we always talk about that when we are working towards a product, any product it may be, on a project level, on a program level, it is necessary that an organization has the effective governance on it, and this is through the quality standards like ISO 9001, which Christoph mentioned clearly. It's the base where we start from, and at the end what we are reaching towards is the product liability. And with the introduction, as Christoph said, that the theory people have got up of why the verification and validation is important, this also shows that they know now that not only system but also hardware and software engineering processes along with the adaptive machine learning processes are also introduced in this new ASPICE 4. And with this new introduction of engineering and non-engineering processes, it helps us to better lean implement the functional safety and cybersecurity standard. And being when we talk about these different unsafe, unsecure, and unreliable scenarios, we see that many work products from our customer projects always talk about this correlation between safety and security, as the ideal principle is that there is no safety without security, and safety should not be a blind spot for your cybersecurity programs. And this is what we also preach and also follow to our customers, and this is what we also do when we do our trainings on ASPICE, functional safety, and cybersecurity, which you can also join when you want. Then in this trainings we actually go in depth more upon this approach, and from our real life hands-on projects we explain that how can this lean implementation be achieved so that at the end product liability is achieved.
Thanks, David, for this hands-on guidance, and we will come more with more examples. But as David pointed out, 1 hour is not enough for all the details, but I hope we get an eye-opener that on the relevance of treating standards coherently and not independently. Okay, a few words on the UNECE regulations. We have the R.155, the R.156. I hope in the meantime known by everybody, applicable since 22 for new vehicle, and 1st of July this year, that is literally this week, Monday, applicable for all vehicle, including legacy. We have many questions now from customers about what it means in the legacy environment. We are aware that legacy always goes back into each single ECU. If you go to the hardware level, it's almost impossible to ensure that you have unchanged equipment. If you think about chips which are changing typically more on an annual basis compared to any more duration, it's impossible to keep an ECU stable. And that means, formally speaking, all changes to the ECU in terms of the hardware or software would need a new homologation. Currently, we have this kind of interpretation by our different regulation and homologation authorities in Europe that they would not really treat the hardware as new as long as it is in terms of specification clearly stating that there's a functional equivalence, understanding that it will certainly always have new functionality, but the base functionality would not diminish. This is important to know because otherwise, if you make a single small change, like you have that old vehicle, which is like 5 years on the market, and it goes to a service station, you need 2 or 3 new ECU with their respective software. Most typically, this hardware is not anymore the same as was used for the initial homologation. And in that case, you have to be very careful. In aerospace, rules are more rigid. It must go into new homologation or certification in that case. In vehicle currently, as long as you can express the functionality is identical, it's fine. All that, we work a lot with the homologation authorities, so if you have more questions, you contact us. Now getting into 21434, briefly, what you can see is the complete overview. It's structured in a way similar to standards like 26262. So you have the core, the product development, which is structured with the V. You have the, let's say, activities which are used across different product development, such as procurement, such as different standard processes. And you have organizational processes which are relevant for achieving a security culture. And all those together give the complete picture, which means you have organizational level, you have project level, you have these distributed activities, and you have the development activities. And you have a special section that is a lesson learned from 26262, which ensures that the TARA is based on a clear understanding. In 26262 edition 1, this was not done, and in consequence, we had for rather long time always discussions now how to do a HARA. And the TARA has examples. Vector also contributed to this standard. And that gives you a better understanding how to best use the TARA. ASPICE, I mentioned ASPICE is new, so you have a couple of changes. Specifically, we have, in the meantime, the validation. Finally, we really pushed for it many, many years. Never understood why it was not explicit. We are glad it is there now. You have hardware engineering, that's also new, and that helps also to have a much better systems engineering perspective. And in that sense, it's also easier to use. We also have machine learning, which applies to AI. So the whole ASPICE is much more consistent with actual engineering practices, not anymore so theoretic as it used to be. At the same time, ASPICE 4 has reduced its volume. It was already getting quite big. And what they removed was guidance and examples. That's good because the standard should define goals and not prescribe methods. 26262 is still in this direction, too much prescriptive, which a standard must not be. ASPICE is now going in a good direction, but that means, of course, you need interpretation, you need guidance. But guidance how to reach goal is always specific to your own context, and this is why it doesn't belong to the standard. That is where companies like Vector come into the picture. We provide the guidance. We use these standards as a leading software company, and we will also help our customers to use the standards appropriately. Now, there are interdependencies of safety security, which David already mentioned. The HADA-TARA, same approach with risk-oriented engineering. At the same time, you see on the picture on the right side that can cause conflicts. I mean, a very simple conflict is shown here. When you have, let's say, accident sensors, which are typically connected to your emergency call and to the whole set of detection of any sort of accident, which is, for instance, then also used for deciding what to do with the accident. You can have a clear safety goal to unlock doors, but you can at the same time also have, if there is just, let's say, a false positive, or if there is a normal driving, you want to have the exact opposite goal. You want to have no way to unlock the doors from the outside. And this shows in a very small and quite easily to understand context that safety, security, although they belong together, not necessarily always aligned in terms of what goals they have, what methods they use. And that is exactly why I referred earlier that we have to be careful to use best practice. Now, a very important starting point, which we see not really applied, is the security culture. That is more than only governance. Governance is a kind of police function. And although I really esteem police in daily life because it helps us to be safe, in companies, we should not only rely on police. As I say, in practice life, we should also not rely on police as the only gatekeeper. We should live the standards ourselves. And that is often not really seen. A simple example is trainings. I mean, trainings should happen and should periodically happen. Like you join the webinar, make sure that you join security trainings at least once per year to get latest insight into what is the updates on standards. And you can also interact with trainers, which is really worth a lot, because if I go to a 2-day training, you get basically 2 days of consulting for free. And I mean, this is really a lot, because you can really beef up your knowledge. And in terms of culture, it's the awareness on standards, it's the awareness of translating the standards, and also how to best use your own different functions in the company in order to best achieve the security goals. Now, a second important topic which we need to understand is what we call the security case. It's like the safety case, all of the different artifacts which contribute to showing that the security is actually implemented, from plans to production data, etc. So keep these things consistent, keep it accessible in your PLM system, and make sure that the different artifacts are time-stamped so they can really serve as a proof in case of a liability issue. If we now move forward into the topics with the standard, we should always understand these top 3 bars are those where typically we see most, let's say, violation or most misunderstanding. If you don't drive cybersecurity top-down, and this is exactly why NIS2 focused so much on personal liability of the C-level, it's simply speaking because over the years, we just saw too many managers who didn't really care for security. They would say, well, security, that's the responsibility of my IT team. Security, that's the responsibility of R&D. Well, R&D and IT team implement, but the accountability is with the C-level. And we should also consider that accountability. And this is why we need to stress this top tier of the standards, where they are really clear what it means in terms of communication, in terms of the different tools to be used, in terms of how you educate, etc. Now getting into implementation, I mean, that's what we as engineers are typically most interested. Cybersecurity applies for the whole V, and that means we start at the beginning with the assessment, with the TARA, that is the understanding of what are the threats and what appropriate risk we do. So it's a threat analysis and risk assessment, TARA, starting with the item, similar to safety. I mean, the item is what needs to be protected. And then we look into what are the assets which relate to this item, which could theoretically also be outside. Often they are outside the item itself. And then we look into how can you actually attack such asset, and that gives you the threats. And with the threats, you can make some rating and also identify what would be now different type of attack paths. And that gives you the risk in terms of the window of opportunity, the feasibility, and the impact or severity. And with that, you can then make a risk determination. And at the same time, and that is much more important than all the theory, because the TARA, we see many companies, they have the TARAs, but what is much more important is the treatment. What is your decision? Design, life cycle, that means also updates and incidents, but also from a perspective of culture. Don't forget that the majority of incidents ultimately is triggered by topics like requirements engineering, misunderstandings, and social engineering. And that means we have not just to make a design decision or even a patch, we have to really also look to the root causes. And that means starting the analysis, we should look into the typical scheme of CIA, confidential, intellectually authenticity, but also availability, because that relates to robustness and to secured operations, and governance, that means the culture part. And all these five actually determine the way how risks are assessed. And this is also something, and that's why we do it as a circle, which is a life cycle activity. It's not a one-time activity. We take the results. We can, in the TARA, then determine the level of the risk, and also the severity would help us then to come to the cybersecurity assurance level, a CAL. And that again determines then for which parts we should take action, starting with the highest. That's similar to the 26.2. So that is the part, if you want, in the lower right of this triangle, of this matrix. This triangle is where we want to put our emphasis. Now, simple example, a case study from a seat comfort system. As you might remember, I had this example also earlier when I said there was a seat comfort system activated, and after 1 week, the hackers already had a way to use the function without paying for it. So even small things can cause trouble. And here, the seat comfort system, this is about confidential data as an example, where you would then identify what would be the attack path for it. Typically can be inside the car, can be also along the software development, the attack feasibility, the impact can be moderate depending on what you can do. Often comfort functions are considered not so relevant compared, let's say, to a braking system. That's true if you look to it immediately, but if you are able to disturb a driver, that can have almost similar consequence. And disturbing a driver can happen in many ways. I mentioned earlier, the big part of all security incidents is actually due to user experience. And that, of course, means infotainment can be such thing. It can be messages sent to the driver which distract him from driving. All that, from a safety perspective, have practically almost same consequence, as we all know, more recently from the many accidents which happen because drivers are distracted. That means it's not just that the car is malfunctioning, it's much more that the driver is malfunctioning. And therefore, we have to make sure that especially comfort functions, like the way how we inform driver, but at the same time also in terms of supervision of the car, is the driver really alert? These are topics which we have to deal much more exhaustively. And on that basis, we can come to a cybersecurity assurance level and identify goals. So here it is low, but of course can also be higher. Now, in terms of design, we recommend always what we can call triple peak, which you might know as an analogy. We have the requirement, we have the design, we have the test, and these are related to each other. So we have typically starting on upper left, we have market requirements, we have product requirements, we have component requirements, and in the middle, we implement accordingly with the traceability. And in the right side of the V, we have to test accordingly, specifically in functional safety and in cybersecurity. We have in safety the MISR rules. We have in security MISR and CERT. This is used on the lower part with static analysis and unit test, and we move upwards into more specific security test. Traceability helps a lot with understanding what to do if there's a change, because often companies which we work for have no real traceability in terms of what's our regression strategy. So there would be a software change, but how much to test and how to make sure that you test all what is relevant and impacted by the change, that's a weakness. And that is also why we must always talk about security by design, that's the forward level, and security by life cycle, which means that we continuously understand also over the life cycle how we maintain cybersecurity. And this is exactly where we see in practice a lot of weakness that too often in the left side of the V, the design, this is what you, if you want that you find in all books, in all literature, in all courses, which is the more obvious, but the right side of the V, the maintenance, the operations, this is where actually the vulnerabilities are proliferated. And therefore, security by lifecycle is really an emphasis we want to give. And maybe, David, you want to also share here some experiences on what would be one or two cases where you saw that security by lifecycle as really important.
Yeah. So security by life cycle, as you mentioned, is like it's neither that you can only do security by design or you can do only security by life cycle. First, we have to understand is that it's the combination of both that is needed, and that's what also the red box tells us is that we have to combine the thoughtful security by design and security by life cycle. One such example is the advent of SBOM, where we talk about software bill of materials. That is, as we know, in an automotive tool chain or when we are developing a product as a supplier, as an OEM, automotive tool chain is not only consist of one software component, but it is consisting of many components and interaction of components that are related to each other. And to do that, so that when there is a new update through SUMS that you have to release a new security patch or you have to release a new software update, that is what we talk about in life cycle updates. In this case, what we have to always think about is that which of these components through our SBOM are affected, and based on that we can then release a new software update. Also, it helps SBOM not only helps us to track what licenses we have, what tools are we using, what components do we have in our product lifecycle, helps us to manage it. But also, when will Christoph will talk about in certain slide in the next slides, when we talk about incident management, that is going where your product is actually on the road. In this case, when the new attack has been occurred, like in the case that we saw the Tara for, that there has been a seat comfort error, there's a new software that has been released, then how would you basically fix this error is by analyzing which of these components are affected on SBOM, and then you create an update, and by using the concept security by lifecycle, you release an update through SUMS. These update is raised to the dedicated RxSWIN. And this whole concept in depth is also what we see in our trainings and also in our different projects that we are preaching and that we are following since a long time, since many long years. So that's it. That's to over to you, Christoph.
Thanks, David. And indeed, always consider to connect both, not just the design, but also the life cycle. Now, one life cycle topic is we always have legacy, and legacy means that we cannot put all the nice security topics from the begin into the software. We also have sometimes to refactor software, make it more modern, more secure. And this is what we call outside-in security, where we try to harden, like with an onion, we try to harden from the outside, understanding that the platform change might still take some years, but we can, around a platform with secure onboard communication, etc., make sure that the component, the functionality of the component is still sufficiently protected. Now, also important on the practical side is to understand how different methods contribute and enrich each other. I mentioned already MISRA with CERT, which help a lot together. Cryptography these days is not really the big challenge as long as keys are sufficiently strong. We still have a long way to go until post-quantum will really reach us. Yes, we work on long life cycle, but at the moment we see that post-quantum has disappeared in the gap of the hype cycle. So there are other topics like Gen AI currently higher on the hype cycle. Defensive coding, that's a much more important topic because still a lot of security incidents just happen because of buffer overflow, for instance. Simple C language issues still are really predominant. And if you go to the VNV part, the right side, apply static analysis, do it and use the reports and not just run it and don't care. Unit test with focus coverage, MCDC, for instance, which we also know from 26.26.2. And then all the different scanners and fuzzing tools where you can also certainly use our own experience over the years, and penetration testing. Gray box pen test still the most efficient and effective method for testing along the life cycle. And make sure you do that also in your aggression strategy. This is often overlooked. Now, with this triple peak abstraction, we can also show how to do that. So we move always from left to right in order to keep things consistent, from the need to the solution to the product assurance. And traceability means then also horizontally and vertically make sure and also prove that you have considered these different techniques. And as David mentioned, lifecycle security also means we look beyond the SOP. We look into what would be in the monitoring. We need an SBOM which is kept up to date for the different instantiations. We need a good feedback on vulnerabilities, on incidents into our R&D and then backwards to the patch distribution. And all that together can easily mean 1 to 2 decades where we have actually provide security support. And that is also what is demanded by the regulations. So summarizing on this right side, we have different techniques which build upon each other. There's not the one which is most important. Methods contribute and make sure your aggression strategy is updated accordingly. With respect to the tool chain, also just to summarize here some best practices, use different work products, different tools, and ensure the traceability from the TARA into the different, let's say, specifications up to the level of the respective testing and verification. Some takeaways from this webinar. We talked about standards, make it digestible, make it efficient, really use external experiences, be pragmatic rather than dogmatic. Often we see quality teams which are extremely dogmatic. That's not the idea. Keep it pragmatic. Educate, learn, continuously update your own knowledge. Apply lean security. That's also what David emphasized, that we need to make it efficient. Otherwise, it gets too expensive. Use config tools and techniques to keep work products consistent. The security case needs to be consistent. Use tools wherever possible to enforce rules like a PLM or DevOps tool chain. Avoid siloed approaches, which means, for instance, that you have your safety, you have your security, you have your purchasing, try to work together as cross-functional teams. Facilitate consistency in your risk analysis so that you can really make a risk assessment with all the different impacts, and emphasize merge points of enterprise and product IT. This is often overlooked. This convergence means complete new topics with social engineering, with introducing malicious code snippets for all sort of update mechanisms which are not anymore controlled as rigorously as during the initial development. We are currently, of course, also looking forward into how can we further drive cybersecurity, for instance, with Gen AI. These are a couple of examples, starting with semi-automatic TARA generation to proliferating heuristics into making our pen test, gray box pen test, for instance, more efficient with Gen AI. So there's a lot of things where in the future we'll see also more solutions from our labs. And along that, we have a big set of cybersecurity solutions, from the services to the base software to the tools. And we also have lots of information, trainings, YouTube, white papers, books. So use it, grow your competencies. And with that being said, I also come to the end of this webinar, but not to the end of the full webinar. We still have 5 minutes left, where David will summarize some 2 or 3 key questions which we received throughout the webinar.
Yes. Thank you so much, Christoph, for a very good and informative webinar. So as usual in the last 30 minutes, you receive so many questions that you have to also type very fast. So that's summarizing the 3 or 4 major questions. So first was regarding the use of the coding guidelines and use of coding metrics. So as Christoph emphasized in his slide for verification and validation as well, right? So we have to not only talk about the left side of the V, but when we talk about the twin peak or the triple peak approach, this is where we talk about the negative base test requirements. That is why verification and validation is important. And starting from the unit level, that is starting where you are actually developing the code, that is where you have to be very prominent that you are not violating any these violations, because these can, as you remember the image that we saw, this can lead to security risk, because we see 30% of the attacks that occur today are due to the unsecure code. That is, there are not been violations or are not been considered the violations of these metrics, which is a very simple check that one could do by using a static code analysis. The second questions that many of you had asked is, wow, what is this NIS2? So this NIS2 is basically a EU directive. The European Union has basically, along with the UNECE regulation R155, it is basically a directive applicable for very high risk industries. As Christoph mentioned, it is not only defines the liability of the organization, but also liability of a high ranking level C personnel in an organization, what are his liability towards the cyber security. Along with that, it also provides you the articles of how your computer's security incident response team, your product security incident response team should be structured, and how do you do incident management. Simple example, how can you do the incident management? What are the incident response times that you have to do, whether from 24 hours to 48 days? What are your different metrics and what are your different work products that you have to deliver? This is all mentioned in this too. And along with that, we also have another European Union directive called as Cybersecurity Resilience Act, which is a mandate. The Article 13 of the Resilience Act mandates all the Tier 1 and Tier 2 suppliers and also the OEMs to show their compliance towards cybersecurity, that is ISO 21434. Hence, as Christoph mentioned when he was talking about the Chapter 5, 6, and 7, where most of the violations occur, this is why that the assessments and audits are necessary, and this is what we at Vector Consulting provide a one-stop shop approach, is that we not only help you coach, not only help you support that to pass the audit and assessments, but our independent and objective team are also able to conduct these audit and assessments for you. So if you have these, feel free to contact us, feel free to reach out to us. And with this, we are coming to the end of the session, and over to you, Christoph, for the final notes.
Yeah, thanks, David, for giving these answers. Thanks to all of you for listening and watching this webinar. For those who joined online, thanks for your many questions. Seems to be overwhelming. And at the same time, for those who listen online, you got hopefully a lot of pragmatic insights from our experience, and I would hope that you can benefit from it. And of course, contact us for any further support. I thank you for joining in today's webinar, and stay tuned for all the other webinars. Bye.